Thank you, everybody. I hope everybody enjoyed the poster session and has enjoyed the talks thus far. We are at over 770 participants in the SRBR meeting. This is really exciting. As people are coming into this presidential symposium, I am really honored and pleased to introduce our two speakers today. Let me give you a little bit of history about the presidential lecture series. This is a tradition that dates back to at least 1988. And prior presidents have selected speakers for this symposium around themes like time, sleep, and memory, circuits, genes, and behavior, and time for a new view of clocks. In the last 16 years of recorded history, we've had 19 presidential speakers. They were all scientists we knew. 4 of them were from outside the US. 2 were women. 1 had a Nobel Prize, and another one went on to get a Nobel Prize. This year, we'll hear from 2 speakers. Both are fascinated by sleep, its mechanisms, benefits, and its disorders. Both are pioneers. Both are working to lead us into new and exciting directions in terms of understanding the importance of sleep. Both are writers with impressive publication histories. Both have been invited to give TED Talks, but they are dramatically different people in their backgrounds and in their approaches. So when I was thinking about who to invite this year, it was a real challenge because there are so many exciting people in our field. And what I ended up deciding to do was invite Ying-Hui Fu from UCSF and Julie Flygare from the Project Sleep. Our first speaker is going to be Ying-Hui Fu, and I'm going to introduce her briefly. Ying-Hui is a remarkable scientist who's worked on neurospora, mice, flies, and people. She started her career out as an undergraduate in Taiwan. She got her PhD at the Ohio State University and did a short postdoc there. And then she went on to switch fields as a postdoc and moved to the Baylor College of Medicine, where she started her work on human genetics. She then took about 4 years and worked in industry as a scientist at Millennium Pharmaceuticals and then at Darwin Molecular Corporation. And then she moved in 1997 to the University of Utah, where she became an associate professor, where she rose through the ranks as a professor. And then in 2002, she moved her lab to UCSF, the University of California, San Francisco, in the Department of Neurology, where she has continued her amazing career. We know her for her work on circadian and homeostatic control of sleep. But many of us wouldn't know, unless you looked her up, that her top-cited papers that have been cited thousands of times, are actually on Fragile X, something that she started as a postdoc. And she's done important work there, helping us to understand the impact of triplet nucleotide repeats and how those are the underlying cause of anticipatory disorders, where the disease gets worse with subsequent generations of inheritance. Diseases like Fragile X and other syndromes like Werner's, Anderson's. She also studies muscular dystrophy and seizures. She continues to work on the genetics of human demyelinating diseases. But Ying-Hui's research is really particularly relevant to all of us here because in studying sleep, she's had this remarkable path of identifying rare genetic variants in human populations to help her dissect the mechanisms that allow some people to wake early, for example, at 3 o'clock every day, or to have extraordinarily short sleep cycles, like 4 to 5 hours a day. Her strategy is remarkably systematic, and I'm impressed by how careful she is. She often takes these human polymorphisms that she discovers in rare populations and moves them into animal models to test causality. She'll take human mutations and put them into mice or fruit flies and help us understand the molecular and cellular basis, and in some case, understand the potential therapies for a variety of sleep syndromes or disorders. She's been recognized with many awards, including in the United States in 2018, being elected to the National Academy of Sciences and the National Academy of Medicine. She was also elected to the National Academy of Sciences in Taiwan. We will try to take some questions after Ying-Hui's presentation. Ying-Hui, if you're ready, please take it away. And thank you very much for being here today.
So it's my honor to be able to present at this very special SRBR 2020 meeting. And I want to start my talk by introducing or acknowledge two of my longtime collaborators. The first one is Chris Jones, and Chris retired about 2 years ago from University of Utah. The other one is Louis Potacek. He's also at UCSF. All right, so we use this approach to study human sleep behaviors. We first identify human subjects with interesting sleep behavior traits, and then use their DNA to identify mutations that are responsible for these behavior traits. And usually that's what I say, and that took me, 5 to 10 seconds. But in reality, from the first email that we received from the human subject to the point that we identify a candidate mutation that we feel good enough to proceed to make mouse models and carry on further study, it takes years of hard work to get to that point. Now, when we find mutations, we then make mouse models. Most of the time we use mouse models and to help us understand the mechanism, and also carried out in vitro molecular studies. And we hope that by using these different approaches, we will learn enough so that someday we can come back to help with human sleep conditions. So for the last over 20 years, we have focused our attention on 3 phenotypes. The first one is for people who always go to bed very early and always get up very early. And they are morning larks, and we call them advanced sleep phase. The second group are the people who go to bed late and get up late. And they are night owls, and we call them delayed sleep phase. The third group is the people who either lifelong or most of their life, they sleep shorter than general population, and we call them natural short sleepers. And these 3 phenotypes actually can be divided into 2 categories. The first category is about sleep schedule, and this is all about what time should you go to bed and what time should you get up so that you will feel good. It's best for your body rhythm. The second category is about sleep duration, and this is about how many hours of sleep you should get or you need to get in order for you to feel good, and also is good for your long-term health. And today I'm going to give you a brief summary about what we have learned by studies mutations in for the sleep schedule, and then I will focus my attention on our more recent data on sleep duration. So our research program on sleep really began in 1996 when Betsy Thompson, this woman, came to University of Utah to see Chris Jones. And she told Chris that she had a lifelong problem of always had to get up very early, always had to go to bed very early. And in her view, this was a negative trait. And she was very worried because she saw her granddaughters also had the same trait. Now, Betsy, till this day, remains to be the only woman, only human who is willing to go into time isolation chamber for 3 weeks in order for us to measure her body rhythm, which is 1 hour shorter than most people. Now, Betsy and many of her family members went to University of Utah Clinical Research Center so that Louis and Chris could study their sleep behaviors. And what Louis and Chris found was that their sleep schedules and sleep qualities and quantities are normal. And the only thing they could find different between Betsy and her family and the general population is that their body schedule is shifted forward by 3.5 to 4 hours. Now, because the body schedule shifted forward is the only thing that's different between Betsy and her family and general population. So this phenotype is called advanced sleep phase phenotype. Now, over the years, we have found several mutations for advanced sleep phase syndrome. We found mutation on PER2 and PER3, CRY2, and CK1 delta and epsilon. Now, from our studies on these proteins and mutations, we found that transcriptional repressed activity and protein stabilities of these proteins are very important for us to maintain a normal body rhythm. We also found the mutation on timeless, and we were interested in timeless because timeless role in Drosophila was well established for a long time, but in mammalian was less obvious or less clear. And we decided to look into timeless more. So we made both back transgenic mice and CRISPR mice, but we couldn't see obvious phenotype, and we actually didn't see period change at all. And that's when we decided that maybe we should listen to the advice that the expert David Weaver had been telling us for many years, that we should use skeleton photoperiod to look at our mice. Now, when we took up his advice and used this protocol, here you see that you use two 15-minute light pulse separated by 11 hours, 45 minutes darkness. You see the wild type mice here in trend very nicely, just like 12-hour light, 12-hour dark. But the mutant mice, then you can see that the mutant mice started the behavior before the second light pulse came on, indicating that these mutant mice are like human subject, also have advanced sleep phase phenotype. So for the timeless mutation, we found that the mutation changed protein stability and also transcriptional activity. But in addition, timeless mutation also changes nuclear localization. So what have we learned from all these mutations that we found in the molecular core clock? We found that the protein stabilities, transcriptional activities, and protein-protein interactions among these core clock components and nuclear localization, they are all very important in order for us to maintain a normal body rhythm. But there is another point I want to bring up here, and that is that from our observation, it's clear that the phenotype that we see in the mouse model usually is smaller than what we see in the human subject. Now, actually, this is a phenomena or a fact that people study mouse models of human diseases have known for decades. But in the behavior realm or in this audience, is less widely accepted. But from our study, it's clear that behavior, just like diseases, mouse phenotype is much smaller, oftentimes much smaller and smaller than what we see in the human subject if you just put the same mutation into the mouse model. So now I want to switch my attention to talk about sleep duration. Now, we have been studying this group of people, we call them natural short sleepers for a while. And this is an example of activity recording for one such subject. And this person on average sleep 5 hours a day here, as you can see. And we have so far studied many of these natural short sleepers. And we found that there is a series of traits that's very common for these short sleepers. They are usually very optimistic and enthusiastic. They also are very active and they are excellent multitaskers. They usually have more than one job, or they have one demanding job plus several hobbies on the side. They also don't experience jet lag like us. And many of them have high pain threshold. And also many of them have told me that they have better memory, they have excellent memory, better than most people. Now, another important point I want to bring up here is that these people actually live a long, healthy life. So they maintain a long health span despite that they sleep much shorter than the rest of us. Now, back in 2009, we reported the first mutation for natural short sleepers from a rather small family. And the mutation was found in this gene called DAC2. And in fact, Sato Homa's group had already shown at that point that DAC2 is part of the molecular clock, and it serves as a transcription repressor that can bind to EBOX directly or interact with transcription factors to regulate gene expression. So Arisa, when she was in our lab, she carried out a project on DAC2 mutation, and she found that wild-type DAC2 can interact with MyoD1 and E1247 to regulate orexin's expression. Now, mutant DAC2 has a reduced affinity to MyoD1 and E1247, and therefore lead to increased orexin expression. Now, to confirm this result, Arisa then fed both wild-type or mutant DAC2 mice with either PBS or orexin receptor antagonist. Now here, you see that the DEC2 mutant mice sleep much less than the wild-type mice with PBS. But if she fed these mice with an antagonist, then the short sleep phenotype in the mutant mice was significantly canceled out, suggesting that DEC2's role in sleep regulation is at least partly going through orexin signaling pathway. So the second mutation we found for short sleepers was on the gene called ADRB1, encode for adrenergic receptor beta-1. And the paper was only out last year, so it took us 10 years to publish the second mutation. And this project was carried out by a postdoc in the lab, Guangzhen Shi. And the mutation was found in this medium-sized family, and the mutation carriers on average sleep 5.7 hours, which is about 132 minutes shorter than the control subject. Now, ADRB1 mutant mice on average sleep 55 minutes shorter than the wild-type mice in black here. Now, this is consistent with what we saw in the circadian rhythm phenotype, that mouse phenotype is much smaller than the human subject. Now, for ADRB1's case, the difference in the sleep is mostly seen in the dark phase, but not so much in the light phase. Now, for ADRB1 mutant mice, and presumably for human subjects, they sleep shorter. There are two possibilities for this. One is that these people and mice just don't accumulate as much sleep pressure, so it takes them longer to accumulate enough sleep pressure so they will, for them to go to sleep. The other possibility is that they also accumulate sleep pressure like the rest of us, but for some reason their body can tolerate higher sleep pressure than us. So to distinguish these two possibilities, we look at the delta power for our mouse model. Here, as you can see, that at the end of the dark phase or beginning of the light phase, in other words, at the end of their active phase and beginning of their rest phase, the mutant mice in red here actually have higher sleep pressure than the wild-type mice, indicating that the mice, and probably human too, do accumulate sleep pressure, and for some reason, they can tolerate higher sleep pressure. Now, Guangzhen wanted to know, how does ADRB1 mutation lead to the short sleep phenotype? But he first needed to show that ADRB1 neuron activity actually has something to do with the sleep and wake state. So he decided to use fiber photometry to look into this. Now here you can see the calcium activity indicating ADRB1 neuronal activity. The activity is always coincide with REM sleep in red here, or wakefulness in yellow here, according to the simultaneous EEG recording. And this is just example from one mouse, and he did it for many mice to confirm that indeed ADRB1 neurons are active during wake and REM sleep, but quiet during non-REM. But to address the question about the mutation lead to short sleep, he then crossed ADRB1 Cree mice with ADRB1 mutant mice to generate ADRB1 Cree wild type or ADRB1 Cree mutant mice. He then used, again, fiber photometry to measure both light phase and dark phase in the same mouse. That way he can use the light phase as a baseline for dark phase, because mice sleep most of the time during the light phase. So the light phase can serve as a baseline. In this way, he can compare among many different mice. And what he found after he did for many mice, he found that the ADRB1 neuronal activity is significantly higher in the mutant compared to the wild type mice. Now, to confirm that this is indeed a cell autonomous effect and not some random secondary effect, he then carried out a single cell calcium imaging with brain slices here. He first took wild type brain slices and put the dobutamine on these slices to see how many different kind of neurons that he can observe. And he found that the first type that is the type that can be inhibited by dobutamine. Second type is no change, and third type can be activated by dobutamine. He then did this experiment with many brain slices from both wild type and mutant mice and counted the number of these neurons. And what he found was that the type that has no change, shows no change, or can be activated by dopamine, the numbers are very similar between mutant and wild type mice. But the type that can be inhibited by dopamine, actually, the number is significantly lower in the mutant compared to the wild type. So what this result told us is that the mutation on the ADRB1 can lead to decreased inhibitory type of neurons, therefore lead to increased ADRB1 neurons in the mutant mice, increased ADRB1 neuron activity in the mutant mice, and therefore lead to a short sleep phenotype. Now, the third mutation we found is on this gene called MPSR1, and this encodes for a receptor for neuropeptide S. And this project was carried out by a postdoc in the lab called Li Juanxin. And in this family, the mutation carriers on average sleep 180 minutes shorter than control subject. Now, for the MPSR1 mutant mice here, you see that on average, they sleep 71 minutes shorter than the wild type control mice. Again, consistently that we see that the mouse phenotype is smaller than the human phenotype. And for MPSR1's case, the difference can be seen in both light and dark phase. Now, just like ADRB1 mutant mice, we also found that MPSR1 mutant mice also have higher sleep pressure at the end of the dark phase and beginning of the light phase, indicating that these mice also can tolerate higher sleep pressure. So this then brings me to this point I want to make here. Now, we all know, or most of us know, about this two-process model that we know that process S and process C together work together to regulate our sleep behavior. But Louis and Chris, for many, many years, have been saying that based on their observation among our human subjects and from literature, they would predict that there will be other processes also involved in regulating human sleep behaviors. And so from our results of ADRB1 mutant mice and the MPSR1 mutant mice, we now think that there will be at least one more process, and that is behavior drive, that is also participating in regulating human sleep behaviors. And the last piece of data I want to show you here is about memory. As I mentioned earlier, that many of the short sleepers told me that they have excellent memory, and some of them have like incredible stories to tell me. So we decided to use our MPSR1 mouse model to look into this. And so what Li Jun did was that she used a contextual memory test because contextual memory had been shown to be sensitive to sleep loss. So he took both wild type and mutant mice and trained them under either light phase or dark phase, but the results are the same. So we can just look at the light phase here. She would train them and then either let them go to sleep like regular condition or sleep deprive them 6 hours and then let them go. And what she found was that if she didn't sleep deprive these mice, both mutant and wild type mice will remember a lot of what they learned one day before. But after 2 days, both wild type and mutant will forget a lot of what they learned, indicating that their memory extinction process is intact. But if she sleep deprived these mice, then you see that the wild type mice actually forget a lot of what they learned the day before. But the mutant mice will behave as if they didn't go through sleep deprivation at all. They remember just as well as without going through sleep deprivation. And after 2 days, they both forget a lot, again indicating the memory extinction process is intact. So this result would suggest that the memory for the MPSR1 mutant mice is resistant to sleep deprivation conditions. So for us to fall asleep, our whole brain circuit or network needs to work together to shut our brain down so that we can fall asleep. Similarly, our whole brain network needs to work together in order for us to become fully awake. What we're trying to do is we are trying to identify important players in this network by using human genetics methods. And we hope that by identifying more and more of these players, it will help us someday to really understand how our sleep duration is regulated. And with that, I'd like to acknowledge again my collaborator at UCSF, Louis Patajek, and a group of very outstanding, fabulous people, including postdoc, students, and staff in the lab. And also our collaborator, Andrew Crystal and Liza Ashbrook at UCSF. They are sleep clinicians. They are carry out studies on the human subjects. And thank you.
Thank you so much, Ying-Hui. Remarkable tour in 20 minutes. I'd like to invite the audience, if you have questions for Ying-Hui, please type them into the Q&A. Ying-Hui, are there downsides to the NSS phenotype? It sounds like a great thing to have, from Jesse.
Yes. All I can say, we're still trying to find a downside. After many, many years, we, at least to me, we have not found anything that's negative. I mean, if you don't like to be very active, then maybe you view this as a negative. But in terms of health and everything, it looks like they're, you know, they're doing fine, and they usually live a long, long life. So.
Fantastic. Jake Huey asks, do you know if the sleep mutants in mouse or human might have altered procedural memory in addition to declarative memory?
Yeah, so we haven't really looked in depth on the memory, you know. So that's a good question, and we should maybe use our mouse model. But I can tell you that not every model has memory phenotype. Just like human, not all NSS people have excellent memories. So, okay. So I guess the answer is no. We haven't looked into that.
We're getting a bunch of questions now. From Quinn Eastman, do you think it will be possible to find strong long sleep mutations, either in the circadian rhythm genes or other genes?
Yeah, so the circadian rhythm, it's a difficult, it's much more difficult to characterize these people. But the long sleep phenotype, we just started to try to collect these people, because, you know, it's usually people email us, and then we used to say, oh no, we studied short sleeper, and now we're saying, okay, yeah, we're also interested. So it might take 10 years to tell you the story. Okay, hopefully I will still be around.
All the long sleepers in the audience should email you though?
Yes, yes. Anybody who will hear this talk, if they are long sleep, especially if they have family history, please email us. Yes.
Super. Okay, a question from Ting Chong-Suan. Is there any effects of aging on the sleep behaviors of the natural short sleepers?
I want to say not that I'm aware of, because we just recently studied a whole bunch of 70s, people in the 70s, late 60s, and they seem to be still going strong, like when they were young. Yeah,
would you say,
yeah.
Yeah, would you say it's more persistent, that the sleep phenotype in the NSS folks persists for longer in life?
Yes, I think they do, at least from what I can tell, they seem to be a whole life. You know, some of them started since they were very young, and some of them started at the teenage, but usually they last, you know, as long as they live, most of them.
Okay, another question. This one's from Eric Music. If orexin antagonist prevents the effects of the DEC2 mutation, do you expect orexin antagonist drugs now being used for Alzheimer's disease to have negative effects?
Well, well, I don't know. I don't think I can answer that without study, without in-depth study. Yeah. Yeah, I don't know. I can't answer that question.
You guys can
I think we need to, yeah, I think we need data to answer that.
Martha Gillette asks, are these sleep-regulated genes differentially expressed in different brain regions? Your last model
Yes.
suggests this.
Yes. Yes, some of them. Yes, I think the answer is yes. Not every gene expressed the same level in all parts of the brain. Some genes express more widely than others, but they do show that some areas are higher than other areas. Yeah, they do show that, yeah.
Do you want to highlight a couple?
Well, for instance, the NPS, oh yeah, hold on. The NPSR1 from the published data paper says that they ubiquitously expressed everywhere, but we have data now show that even though they are widely expressed, but there are certain areas expressed higher. And similarly, ADRB1 is considered widely expressed, but from our data, it clearly show that some areas are higher than others. You know, so all this. DEC2 is a very painful to study because it expressed very, very low, but again, it shows higher in some areas, even though it's very, very low.
We have a question from Sagi Nujumi. Are those who are natural short sleepers like this, even as children and teenagers, or are they natural short sleepers at different times in their life?
Well, most, I want to say some of the natural short sleepers say that they have been that way ever since they were a little kid. And some say that they started in teenagers, but they usually last the whole life, like I say. So some kids and some short sleepers, their children are like them. So I think that some started very, very early and some started about teenage years.
Okay, I'm gonna give you two more questions, okay? In 2 minutes. And there are many more. I'm going to encourage the audience to write to Ying-Hui with your questions. Danny Forger asks, could we screen for short sleepers and circadian effects with large-scale wearable data and find new mutants for you?
Possibly, yes, yes. You mean, what do you mean by find mutation for us? Find individuals for us or find mutations for us?
I think it would be individuals, right?
Individuals, yes.
Are you using a lot of large-scale wearables or other things?
We don't use that. We have, again, like I said, it's all people email us, volunteer. And just by that, we have more than enough. You know, we have more than we can ever handle, actually. We have more human than we can ever find mutations for.
Oh, wow. Fantastic. Okay, one more question. This one's from Mick Hastings. Can you speculate on the mouse versus human cause of the differences in severity?
Yeah, this is a phenomenon that people have known for many years. And as most people know, that Louis and I, we started our career by studying diseases. So we knew about this. And I think there are many reasons for this. One is that we are just different from mice, right? The other is that mouse just don't live as long. And so with the disease and behavior, well, that makes sense in disease, but in behavior is less of a connection. But I don't know. I think that I usually use this as an example, the triplet repeat expansion disease. Now, in the human conditions, if you have 50 repeat or higher, you most likely will manifest some kind of phenotype if you're human. But in the mice, if you want to make the mouse model recapitulate or similar to human conditions, you'll need to give them 150 or 200 repeats or higher in order to see the phenotype. And so this is something that people have known for a long, long time, but in the behavior is less accepted. So you know, the reason why, I don't know, all I can say is probably the mechanism is still different. And they also don't live very long, right? Mice don't live very long. So less time to manifest all the things are required to manifest.
That's an interesting point, yeah. I thought you were going to talk about congenic versus polygenic backgrounds.
Oh, no, this is, no, no,
Okay.
this, yeah.
Well, on behalf of the 300 plus people who have tuned in, I will applaud for you. Thank you.
Thank you
very much.
Thank you. It's my honor, my honor.
When I was thinking about whom else to invite to speak in the presidential symposium, I wanted somebody who would challenge all of us to think about the big picture of our work. Enter Julie Flygare. I first met Julie about 2 years ago on a trip to DC. We had spent the day going to various Senate offices to talk to them about the importance of funding sleep research and the future of sleep research. We got seated next to each other at the end of the day at dinner. And I was struck by her. She was smart, engaging, and she seemed to know every government official who walked in the door. She knew Rand Paul by sight. It was amazing to me. I'll never forget it. And she was also really curious. She asked lots of questions about sleep regulation of the other scientists at the table. I knew she had written a popular book about sleep, so I went home and I bought it. And it sat on my shelf for a couple of months. And then I actually saw Julie on the news, and they were talking about her as the REM runner, the rapid eye movement runner, because she's an avid runner. And she's this remarkable woman who runs a lot to raise awareness about narcolepsy. So I picked up the book again. It's called Wide Awake and Dreaming, a Memoir of Narcolepsy. And in the book, you learn a little bit about Julie. She was an undergraduate at Brown University in the United States and got her degree in history of art and architecture. She went on to law school at the Boston College of Law. She graduated with her degree. And then she worked for a bunch of years in various positions, marketing, communications, and development, usually with connections to sleep and to helping out others in the community. In 2012 until 2015, she served on the NIH's Sleep Disorders Research Advisory Board. And in 2013, she founded Project Sleep, an organization that she runs to this day. She publishes, if you read her book, it really sticks with you. It's really amazing. She also has published some scientific articles, usually talking about people-centered language in educating people about daily sleep, including how to educate physicians on how to ask questions about sleep. I highly recommend her writings. In her book, one quote stuck out for me. She said, how had the picture gone so horribly blurry that I looked to a dog to regain my bearings? And this was her life. She is honest, she's funny, she's smart, and she makes herself vulnerable while becoming a ferocious advocate for those affected by sleep disorders. Julie graciously agreed to give this presidential presentation, and it's going to be unlike any other you've seen at SRBR. I hope all of us learn something about how we can communicate our work to the public and how the public can remind us of the relevance of our work to everybody around us. So with that, Julie, please take it away. Thanks for being here.
Thank you, Eric. Thank you for that very kind introduction. Thank you guys for tuning in tonight or today, wherever you are. I'm so excited to be with you. This is a huge honor for me to present to you. As Eric said, maybe I'm a little bit different as a presenter than what you're used to. And as I prepared this presentation, I started to realize just how different I might be. Oops, let's see. So growing up, I was very motivated to succeed and involved in a lot of things. Here I am on the left. I was New Hampshire state champion for tennis. Kind of a big deal, except for there might be more cows in New Hampshire than there are people. So I won't go ahead and say it's the biggest honor in the world, but I was just very active as an athlete, and I was interested in photography and art and writing. But I will say that in high school, I distinctly remember the one C I ever got on my transcript was from biology class, okay? Science just really was not my thing. And it always stuck with me that that was the one C on my high school transcript. Luckily, I was still okay, and I got into the school of my dreams, which was Brown University. And I was really excited to go to Brown to study art history and also to be a varsity squash player. I don't know if you guys are familiar with squash. It's a really fun sport. Maybe some of our international folks might even know more about squash than people in the US do. So I also was excited to go to Brown because there was no core curriculum, so you didn't have any classes that you were required to take, which meant I could successfully not take any more science or math classes again in my entire life. Goodbye, science. I focused my attention to art history and creative writing, but it was while I was at Brown that I started to be in class, and a lot of the art history classes were in dark rooms with the projection screens showing paintings on the wall. And I would start to watch the clock in class to think, how long can I wait before I can go to the bathroom to try to wake myself up? Because I was fighting this sense of heaviness sitting on my skull. So I would go to the bathroom almost every single class to do jumping jacks, to pinch myself, slap my face, put water on the back of my neck, all those tactics I'm sure all of us have tried at some point in our life. At the time, I really just thought everyone was tired because it was college. Everyone does too much, and I was a varsity athlete, having practice once or twice a day. I had a busy social life, so I didn't think too much of it. I was 22 years old when I started at Boston College Law School. My dad was an attorney, and he loved being an attorney. He thought it was just the honor of his lifetime. So he actually convinced me to go to law school to study art law, combining my love of art history with law. And it was a really fascinating area. I was still having trouble though in classes. And I also found that when I was doing my reading assignments, I would often find that I had been reading for like hours, but I'd only really gotten through 2 pages, or I couldn't remember anything I'd read. And it was really, really frustrating. And honestly, at about a few months into law school, I questioned whether I'd somehow lost my willpower. It felt like something wasn't quite connecting, but to me, it felt like it was my drive. This felt really important. Law school felt more important than anything else. And the first year is like the most important year, they say. So I really felt driven, but something wasn't quite clicking. And at the same time, I started noticing that when I was laughing at jokes, my knees started buckling under me. And it took me a few times of this happening to realize it was always when I was laughing. So I'd say to my friends, don't make me laugh, don't make me laugh, my knees, my knees. And other times I would be sleeping at night, and I would wake up to think a burglar was breaking into my apartment, and I could see a man rush at me with his arms stretched out to my neck to attack me. And I was absolutely terrified, but I couldn't move to respond to him. And then the next thing I would look up and he would be gone. So at the end of my first year of law school, I eventually found the word narcolepsy. And I remember thinking, narcolepsy? No, I don't have narcolepsy. That's a joke about someone like falling asleep when they're standing or in the middle of a conversation. That's not me. But once I learned about the real symptoms of narcolepsy, I thought, oh my God, this might actually be what I am experiencing. And I really hadn't connected that all these things had anything to do with each other, because they felt like different parts of my life. Excessive daytime sleepiness. Okay, well, I wasn't falling asleep when I was standing or in the middle of a conversation, but I definitely was having a trouble maintaining good cognition and memory. And when I read about cataplexy as a loss of muscle tone with emotions like laughter, I realized that's why I was having trouble with my knees buckling with laughter. And about hypnagogic hallucinations and sleep paralysis, these auditory visual hallucinations when falling asleep or waking up, and then sleep paralysis is that inability to move. I often experience those things together. And so when I read the real symptoms of narcolepsy, I quickly figured out that's probably what I have. So I was lucky to have a great specialist right in Boston, near where I was living. And I got a sleep study, a 24-hour sleep study, and I was diagnosed with narcolepsy just 4 days after my 24th birthday with narcolepsy with cataplexy. And I remember my specialist was just so excited by my sleep study results, because I'd gone into REM sleep so quickly in all 5 of my naps that he couldn't wait to show his residents, I guess, like this is what narcolepsy was like on paper. And I remember thinking that like, this isn't so exciting. Like I didn't really want to be like a great like neurology case. I wanted to be like a great law student. But it was validating at the same time to finally know that all these things that were happening were real and had like a real biological process behind them. We started talking about treatments, and when my doctor started talking about some of the different adjustments I might have to make to my life to incorporate medications, I thought, no, this is way too overwhelming. I don't want to make these kind of adjustments to my life. But I have to back up 4 days because 4 days before this being diagnosed was my 24th birthday. And it happened to be the law school boat cruise. So it was this fun night where we go out on the Boston Harbor. Because it was my birthday, my friends got me this fabulous tiara you can see with glitter and feathers. And it was a super fun night. People were buying me drinks, so I probably drank too much. And the next morning, I woke up and I still had like glitter all over me from the night before. And as I walked to the bathroom though, I thought of something funny, and my body kind of hit the side wall of the hallway and I slithered down to the ground. And I'd experienced cataplexy before, but this was by far the worst I'd experienced it. And I remember thinking in my head, just breathe, Julie. I want to breathe deeper, move a finger, move a toe, do anything. But my body was completely silent to me. And even though it was probably only about 30 seconds to a minute, every millisecond of that, without any control, being alive in my head, but completely paralyzed in my body, was terrifying and the slowest seconds of my life. So if you fast forward 4 days later to receiving a diagnosis and finding out that I would have to take treatments, my doctor wanted me to take treatments twice a night and once a day, I realized that I needed to, try this so that I could improve my symptoms. I still thought that it was going to be kind of I would take the medications and I would be better. It would be like one little road bump, but it kind of turned into a road with a lot of road bumps. Adjusting to treatments, I've learned, is a lifelong journey, and trying to figure out the best tweaking of dosages, how to manage side effects, and also managing symptoms, residual symptoms, since they didn't erase my symptoms all the way. At the same time, it kind of felt like everything else was going wrong in my life at the same time. I didn't get a big law firm job that I'd hoped for. And my boyfriend at the time, we'd been dating about a year, broke up with me saying that we weren't having fun. And I was thinking, yeah, we really weren't having fun. This was not a fun time. But probably the worst thing of all of this, like no matter how serious the symptoms were and all that, it was feeling like no one really quite got it around me. And that actually people even laughed in my face when they found out I had narcolepsy. I just stopped telling people because I honestly hated their reactions. Some people almost thought it was so small, like I'd said I had a flu. Other people seemed to think it was so serious that maybe I wouldn't be able to walk down the street without falling asleep, which really wasn't my experience. But I didn't have the communication tools to explain what it really was. So I just felt increasingly isolated, and I felt really mad. I was fascinated to find out, though, that even though here on the left that people thought that narcolepsy was something like this, the portrayal from Deuce Bigalow, Male Gigolo, in which a woman, falls asleep while she's bowling or falls asleep in the middle of eating a bowl of soup. While people in society thought that that was what narcolepsy was, it was really fascinating to learn about the science and to learn about hypocretin or orexin, and that, so much was already, they'd found out so much about what was causing the blurred boundaries between being conscious and being in dream sleep for me. So even though it was like really fascinating, like the science was fascinating, maybe not living with narcolepsy was fascinating, but I definitely found that at my lowest point, surprisingly for someone that really didn't like science, I took solace in science. It gave me hope too, at my lowest. I felt very isolated for this first couple years, and My dad and my stepmom actually encouraged me, kind of dragging me to go to a Narcolepsy Network conference in which I would meet other people living with narcolepsy. I didn't really want to go. I thought people with narcolepsy might be weird or something. And it was a really fabulous weekend in which for one weekend, narcolepsy was totally normal. People took the same medications I did. And even though the conference had a big effect on me, it might have even had a bigger effect on my dad. So I wanted to read a quick passage from my memoir about the conference experience. On Sunday morning, Dad came into my hotel room to talk over the logistics of the conference and a drive home. He turned to leave, and then he stopped at the door and walked back toward me. Had he forgotten something? I'm so proud of you, Jules. He opened his arms to hug me, which was strange. He wasn't much of a hugger. He'd always been sort of an awkward dad, not the touchy-feely type. He hugged me tightly, and then his body began to shake, and I realized he was crying. Weeping, really. He convulsed in my arms. I'd never seen him cry, never mind felt him cry. It made me so sad I didn't want to hug anymore. I'm so sorry, he repeated between sobs. It's okay, Dad. He finally let me go and sat on the edge of my bed, rocking back and forth and clasping his hands tightly. It was a place he'd seen me many times. He'd listened patiently to my hopeless sobs, most recently with the breakup. I sat next to him on the bed, unsure what to say or do. I didn't understand before, but I get it now, he finally said. It's much worse than I realized. Funny, I thought he'd understood my narcolepsy better than anyone else, but now he thought he got it. It's not your fault, I said. But it's not fair, you're so young. It's gonna be okay, Daddy. This was a white lie and we both knew it, but what else could I say? Eventually he calmed down and left. I looked around the bare hotel room and finished folding my clothes into my suitcase in silence. The conference had a big effect on Dad, perhaps bigger than it had had on me. Now he held his own burden, to love someone deeply, his youngest child, his fabulous Jules, and watch her navigate a serious illness. He'd always been my knight in shining armor, helping me through all my lowest points, but he couldn't save me from narcolepsy. So it was really hard to see him upset, but at the same time, I really needed that emotional support of someone who really got it. Since I was still in law school, I like to say first I got angry and then I got academic. I was fascinated, like I said, about understanding about hypocretin, and I was diagnosed back in 2007. So it had been almost now a decade since they had really discovered the hypocretin connection back in 1998, 1999. So I wanted to know, why weren't there yet treatments yet that targeted the loss of hypocretin in people with type 1 narcolepsy like me? Which led me to study rare disease drug development to better understand all the incentives that were available for people to develop rare disease drugs and what kind of barriers people still faced in developing those treatments. And, so I took great hope from researchers like Dr. Mignot here. I also became really fascinated about sleep in general, that people not only thought narcolepsy was a joke, we didn't really take sleep very seriously either. And it was very ingrained in me growing up that, burning the candle at both ends was important for getting the most out of life. I loved motivational videos, and often motivational videos that talk about, how to succeed in life sometimes have this point where they say that you want to get the most out of life, you just need to get up an hour earlier every day to get everything done, and so I was used to that kind of messaging. But as I learned about sleep and how it was actually this very active process, I realized how had our society got so out of touch with science. And now that I was kind of like a new super fan of sleep science, I thought maybe I could help on a communications perspective to help make sleep cool. When I graduated from law school, I'd really kept my narcolepsy pretty private for those 2 years, like I said, because I didn't like the misperceptions, but I kind of had enough. I'd always been sort of an outspoken, honest person. And so keeping narcolepsy private to me just didn't sit well with me for those few years. And I thought we were kind of caught in this catch-22 where we didn't like misperceptions of narcolepsy. And so often that kept people like myself silent, that allowed those misperceptions to perpetuate and more silence, and that more people needed to break that silence. So I decided to tell my story through writing by writing my book, Wide Awake and Dreaming. And I moved to Washington, D.C. to begin advocating for narcolepsy, but also sleep in general. I was really wanted to do what I could to help fund research. So I ran the Boston Marathon back in 2010 to raise funds for narcolepsy research with the organization Wake Up Narcolepsy. And it was also just an incredible moment crossing that finish line, to know what it feels like in my own body sometimes to not be able to control my own knees, to have the same strength, be the same person that could cross that finish line in 4 hours and 41 minutes, not to be competitive, but the time is not correct there. It was actually 4 hours and 41 minutes. And I also got involved at, as I said, to do advocacy. I found out about NIH's Sleep Disorders Research Advisory Board. I was not on the board when I first moved to DC. Of course, no one knew who I was, but I could attend public meetings. So I just started showing up. And I would take the opportunities during coffee breaks to talk to some of the researchers and clinicians that were on that board. And eventually they did invite me to be a board member as a patient advocate. And that was a really great experience. And I really wanted to kind of understand what was the federal funding for sleep and sleep disorders, and was there enough? I didn't think there was probably quite enough funding yet going into narcolepsy and other specific sleep conditions. So after being involved in the field for a few years, I eventually founded Project Sleep, like I said, to try to make sleep cool, to raise awareness about sleep health and sleep disorders. Here are some of our programming. I won't go through all of it today, but we have a variety of programming. We give out scholarships to students with narcolepsy. So we've given out 68 scholarships to students with narcolepsy or idiopathic hypersomnia as they are starting their first year of college. And next month, we will give out another group of scholarships to students. We're really excited to make that announcement soon. We also train people with narcolepsy on how to share their story effectively, because it's shown through science that storytelling is one of the most powerful vehicles to educate people, especially about illnesses, and to reduce stigma and encourage empathy. So it's a really wonderful program. We have over 60 advocates around the world that are trained to share their story through speaking and writing. And just a few years ago, I'd say it was 2017, the Sleep Research Society, their advocacy task force, reached out to me to ask how we might partner with patient advocates, that they were already going to Capitol Hill to be advocating for sleep research, and how could we bring patient advocates along? And for me, that was a no-brainer. I said, yes, let's do it. Let's partner. And I was so excited to have that opportunity, because I was actually working in my professional life in pancreatic cancer for a nonprofit I was working in that space. I was bringing patient advocates and scientists together to Capitol Hill to be advocating for pancreatic cancer research. So we should do that in the sleep field, where my area of passion really is. And so Project Sleep lays down these principles as our guiding principles for our advocacy program: advancing sleep research, accelerating treatment options for people with sleep conditions, ensuring coverage and access to healthcare. And that's even more important than ever right now, as in the wake of COVID-19, with many people losing their employment, they might be losing their access to health insurance. So we keep very close watch on that. And also furthering awareness and education. I have this kind of really sad example here on the bottom of some of the advocacy work we're trying to, the situation we're trying to change, in which I did a little bit of research, and I found out that Americans consume about $11 billion in energy drinks last year. Okay, $11 billion. And don't tell me anyone drinks energy drinks for their taste, because they're pretty gross. So that's how much we are actually consuming energy drinks. At the same time, last year, the CDC invested $0 in sleep education and sleep awareness. So we're living in a culture in which these companies are offering these solutions for people's sleepiness without ever letting people know that sleep health and sleep disorders are real. This is a problem, and we are trying to, through our advocacy right now, really focus on making sure the CDC has a program so that we can be educating both the general public and healthcare professionals about sleep health and sleep disorders. So through this, we do events in DC, and also we do stuff online. And so some of the in-person events have been some of the best moments of my life. Here's a picture on the left of Phyllis and Fred. I'm sure you both know them. In the middle is Michelle, who is a woman living with narcolepsy herself. And I know from Michelle's perspective, this was just one of the coolest days of her life, and she felt so honored to be spending time. I always hear her say she's a Rising Voices speaker, and she always shares that, she got to advocate on Capitol Hill with someone that sends mice into space, which I believe is Fred's work. So it's just a really wonderful collaboration, I'd say. And here, obviously on the right, is Eric, along with Patrick Fuller, Janet Mullington, and our advocate, Ebony Lay. I believe this group called themselves Mo-Kansas or something. They came up with a clever name because they were from Massachusetts, Missouri, and Kansas. And that was their advocacy team that day. I think it's the power of bringing patients who live with sleep disorders with researchers who have great passion. We're both really passionate, is an incredible collaboration, and really grateful to not only work with the Sleep Research Society, but also with SRBR on our advocacy. So I just wanted to give one example story of another effort. This was an online effort. We had an opportunity to do a congressional sign-on letter in February, late February. And we finally heard from my representative, who is Adam Schiff, that his office would help to champion this letter, that they would step forward and say, okay, we're gonna take on this letter to promote the advocacy agenda of the sleep community, that there needs to be more sleep research, the sleep awareness work. And so we were really excited because now we had this letter opportunity, but we had a very short turnaround deadline. I think we had less than 2 weeks. And this involved getting patient advocates and researchers reaching out to their representatives' offices, and then their representatives hopefully signing on to the letter. So it's kind of this big process in a short amount of time. And I was super nervous, and I really wanted to make sure we did a really good job. And so then it was just less than 2 weeks later, I was super excited to find out that he had actually secured 41 members of the House of Representatives that signed on to that letter. That is almost 10% of the total House of Representatives. And just so you know, because this isn't really my area of specialty. We work with health specialists in DC, but by sign-on letter standards, this was a huge success. Like, getting that many representatives sign on to letter is a very big deal. And we, the sleep research and sleep patient community, had made that happen. It was also bipartisan. We had representatives from 23 different states here, from everywhere from New Hampshire and Vermont to California, Michigan, Minnesota, Texas, Alabama, Wisconsin, all over. It was an incredible effort. And that was due to nearly 200 different advocates, both patients and researchers, reaching out in 28 different states to their representatives to get these people signed on. So you can read the letter yourself. This is what it looks like when you print it out. It's on our website. And it goes to help promote our advocacy agenda and the change we hope to make. And I think the biggest thing that we'll hope to find out soon is whether we secure that CDC program for sleep awareness. I loved how Dr. Fu was talking about how science can be kind of slow, things take time. And I think that is really important to know about advocacy too, and a lot of the successful moments are not really like big moments in the public. For me, when I printed out this letter in my own house by myself, like, that was my moment, of triumph that we have made this step. And there are many, many more steps to our advocacy. Our work is not done, but it was still a pretty cool moment to sit there and watch this letter print out. I just set it on my desk. It's been sitting there for like the last few months since March, and it just sits there. And to me, though, what it is regaining control. Narcolepsy seemed to take my control away from me. And now to have any way to take control and to help support this research process and science is really beautiful and really important for me. I leave these as my challenges to you if you are interested in helping to co-create a brighter future with patient advocates like myself and others. Please participate in the advocacy action alerts that we put out. They're just a few times a year, like the thing we did in February, and we'll have more opportunities. It's really gratifying and rewarding experience to get your representative interested and involved. And to please collaborate with patient advocates at all stages of the research process. I could give you guys a completely different presentation about the importance of this. Here are some of the different organizations and efforts that really focus on making sure that patient advocates are a part of the research process. And thank you to Eric and to SRBR for already understanding the importance in partnering with patient advocates by inviting me to be a speaker. By this year conference, it would be included in the Patients Included effort to make sure that patients are involved in conferences. And the last thing is, let's talk on Twitter. If you're not on Twitter, please join. I think many of you are, so we've already followed each other. But I think that if we want to improve the public discourse, we really need to make sure that we're talking in the public. And when I worked in the pancreatic cancer space, I loved seeing that some of the very best researchers in the field were on Twitter and they were talking, they were having intellectual discussions right there. And I think that the sleep field could use a little bit more of that to help us communicate and reach the public. So those are my challenges to you today. For me, what I'm personally really excited about is I really want to understand the social science side. I want to know, why did that hug from my dad mean so much to me? Where are those pieces missing, and how can we make sure that people with narcolepsy do not have to feel so isolated and alone? And create efforts that help to reduce that stigma and isolation. I also am really excited because this year, clinical trials for hypocretin agonists are starting. So even though I was kind of upset back in 2007 that that step hadn't been taken, I see, yes, the science sometimes the process is slow, but it's so exciting now to reach the point that we are having clinical trials for a hypocretin agonist in America. And I know that is thanks to probably hundreds of researchers, if not more, all of their efforts through many decades now that come to this point. So in closing, I just want to share this quote: "Make visible what without you might perhaps never been seen." I guess we do different things. I thought I didn't care about science, but I realized that you as scientists are often trying to do that, right? You're trying to make visible what wouldn't be seen. And for me, as a communicator, I want us to help communicate the things that are invisible. And so we probably have a lot more in common than I ever imagined. And again, I'm just so grateful for this opportunity. And I'm so thankful for all of your work, and hope to continue working together to build a brighter future. So with that, I'm happy to answer any questions.
Thank you very much, Julie, for sharing your story and what you've been working on so diligently. We already have a couple of questions. Do you have time for a couple of answers?
Of course.
Great. So if the folks on the technical side can just open this up for me so I can read them. We have a question from somebody who goes by BP Offside. Is there a recognized field of sleep law, and are you it?
Sleep law, interesting. There's different legal issues for people with sleep conditions, and I have written, the only area that I could say somewhat that I have really delved into is understanding educational employment accommodations for people with sleep disorders And I did publish a chapter of a textbook with Dr. Thorpe and some other narcolepsy researchers talking about that. Besides that, I wouldn't consider myself like a legal expert in some of the things like driving or areas like, you know, aviation. There's a lot. I would say, you know, even sleep policy is kind of its own field. And I'm not even really an expert in all of that. There's so many different parts of this. So, you know, I really like to work with our health experts in DC who better understand a lot of how all this comes together and how we can really make tangible progress. And, you know, for me, a lot of, I'm not a lawyer probably because some of that stuff does put me to sleep a little bit. I really love communications and more of the public facing stuff. But, you know, I think it's really important and that there are lots of different things that could possibly, you know, sleep law could probably, a lot of different things.
Fantastic. If I can ask one more question. Were there lessons you learned in getting Project Sleep off the ground and making it this real destination for the patients to join in that you would make the circadian and sleep community aware of as they start to look to partner with patients and patient advocates?
Yeah, I mean, I think, Eric, you kind of understand the importance of relationship building. I laughed so hard when you said I remembered about Rand Paul. I don't know if I'd recognize every politician, but Rand Paul, like, I recognize him. You know, it's just kind of those human moments like that we were sitting at dinner together gave us that opportunity to understand each other on like a human level. So building that trust and that natural rapport, I think is important. And then from my perspective, I guess just having an appreciation for the fact that we don't always know what we don't know. And so that's what I mean about really partnering with patient advocates from the beginning. It's not, oh, I have this great idea. I know how to help all these people that have this condition I don't have. And then at the last minute being like, you know, asking an organization like mine or you know, to get involved. Now that you've already developed a solution, start when you're brainstorming about the problem and develop solutions together. And I promise you, you will develop better solutions when you include the voice from the beginning. It's not something to be scared of. Patient advocates, you know, are just average people in a way that is amazing because they have many other expertise, right? I have a background in health policy. There's other health advocates that have scientific backgrounds. So there's just so many different expertise to be drawing from, and to take that multidisciplinary approach very seriously and partner from the beginning. I think, you know, it'd probably be my best advice for that.
All right, on behalf of everybody here, thank you very much, Julie. I will applaud for everybody. It's been a long day, so thanks to everybody who's come today, and we'll meet you all here tomorrow.